Fast API is great, but sometimes you want something with no dependencies and just closer to the middle. Using data classes means we have our own validation logic using post in it, and we don't depend on Pydantic, which is great if you're avoiding third-party overhead. But we're still keeping things clean, typed, and testable. Thing is, with Pydantic, it's slower than data classes, especially before v2 of Pydantic. It's an extra dependency, and it's kind of like magic in a box. The dynamic model generation can feel very opaque, especially when we get to some weird edge cases. Data classes provide built-in validation when enforced, not just hinted. They're customizable, and there's zero dependencies with them. The only thing that Pydantic has over top of data classes is there's no built-in validation. They're a little bit error-prone if you don't cover all of your error cases. You have to manually parse everything from dicts and nested models. It's a little bit tedious. And there's no automatic serialization. We'll have to roll our own .dict or .json logic. So the project that we're building is essentially just mocking up developing structured data and passing it from a client to a server. So our example app here, if we go ahead and fill out the form, we can add a product, select our product. We can switch from this product summary view to the JSON view, and that also allows us to send a post request to the server, and you'll see that reflected here. So we'll do what we always do here, and we will create a virtual environment. And as you can see, we have a folder structure here. We have client.py, dataclassmodels.py, server.py, and textual.css. I'm not going to go over the CSS here. You can look at Textual's documentation for that, but we'll do the other implementations here. Actually, we're going to need to install some dependencies, so we will pip install Flask, Textual, and requests, and I think that's all we need. And when that's complete, we've got some imports. And the first thing that we're going to do is define some enums. And enums are just a way to define a set of named constant values, basically like a category of valid options, and they're often used when you want to restrict a variable to one of a few predefined choices. So if we go ahead and define a provider class, we're going to inherit from string as well as enum. And we are going to set these predefined values as AWS is going to be equal to the string AWS. And hugging face is going to be equal to the string hugging face. And then we're going to override a dunder method, the string method, and we're just going to return self.value. This just ensures that the only valid values, like AWS or hugging face, can be used. And it basically prevents typos like lowercase AWS or hugging underscore face from silently slipping through and we are subclassing both string and enum because this lets each enum member behave like a string. So you can use them in JSON.dumps, you can use them in file names, URLs, etc. And without inheriting from string, you have to use .value everywhere. And then we are also going to have a class hardware type. It's going to be inheriting from string enum as well, capital GPU or CPU and GPU, and we're also going to do the dunder string override. So now we're going to get into the meat of the data classes. So we're going to have a class. Oh, I keep doing that. AI compute product, and that is going to have a name, which is going to be of type annotated. And annotated is kind of like Pydantic's field value. Essentially, it gives parameters metadata essentially at runtime. So you can do things like generate documentation, and your IDE can have type hints and things like that. So we can do name annotated string, which will be the name of the service or instance, and we'll have a provider which will be annotated, and a price USD, which will be annotated in a float. We will have compute hours, which will be annotated and a float as well. Good try, Copilot. We will also have a hardware type, and that will be of the hardware type enum that we have here. And then this provider, of course, comes from here. So we will also define a post in it, which is where we can kind of do validation after instantiation here. So we'll do define post init self, and we're just going to use this to validate that the self.price, if it is less than 0, we're going to raise a validation error. So if self.price USD, apparently I spelled that wrong. If self.price USD is less than or equal to 0, then we're going to raise a value error. And then we're also going to validate if compute hours is less than or equal to 0, we're also going to raise a value error. And this should be self. And then we are going to define our first property here. So we'll decorate that with the property decorator, and then we'll do define cost per hour. It's going to inherit from self and return a float, and we are going to round our self.price USD divided by our compute hours. And we're going to go to the third decimal place here. But this might look familiar if you're coming from the other tutorials, that we're going to annotate this. We're going to pass frozen equals true into this data class, which just makes it an immutable class object at runtime. Next, we are just going to define some helper methods here. So we'll do define to JSON. So we will return, JSON.dumps self.toDict. toDict indentation 4. And then we are going to go ahead and implement toDict now. So define toDict. We'll return a dictionary, and we will d equals, and this is a data class thing, asDict, a method that data classes give you, which converts the object to a dictionary recursively. So if you had nested dictionaries, it would automatically nest that for you. So we'll do d equals asDict self, and then d provider, self.provider.value. We don't need to string that because we did that up here. Self.provider.value, and hardware type and cost per hour, same thing. Cost per hour, and then we will return that dictionary. And then we are also going to override the dunderString method here. So dunderstr this, I'm just going to copy and paste this. We don't have to try to make this tutorial kind of quick. So this is just going to, when you print this as a string, it's going to print this formatted string here essentially. And that'll make more sense when we start working on the textual client. And if we wanted to run this as main, we can go ahead and test this. We're going to ignore this for now because this requires a server. And at this point, we could Python data class models.py. And you can see this print product to JSON prints the output of this here. We can print the string too, just so we can see that. As you can see, this is this formatted string I was talking about here. So moving on, we will go ahead and implement the server next. And here are our imports. And the first thing you have to do with Flask, just like FastAPI, app is equal to Flask, and then we will create our first endpoint. So we'll do app, if I can type, app.route. This will be /receive JSON, and it will be post method. And then our function will be receive JSON and data request.getJSON, correct. And then since we're using rich here, and actually I'm not going to do any of this error checking here. So we're going to do get JSON consoles equal to console, and then we will console.print receive JSON with the JSON data. And then we're going to need to return, because you can't run the server unless you actually return something from a request. So this should work. And then this, let's make this a little easier to read. And that'll be a 200 OK HTTP response. And then here to run the Flask server, we just need this code block. It should seem pretty familiar if you've ever done any web developing before, FastAPI or Flask. And then now we can run the server. Pip. And then we can go back here, actually, if we want to. Oh yeah, and then of course I forgot to implement post JSON. So we can go down here underneath of the dunderstr. We can define post JSON, and we're not going to do any of this. We're just going to have it take self, and then we will, and then response is going to be request.post URL, and then we can do this JSON equals self.toDict. Oh shoot, this is supposed to, of course, this is supposed to be to JSON, not to dict. Yeah, idiot. Anyways, now we should be able to post. Cool. So we got this response back, and then here on the server, you can see that we printed this out all nice because we used the rich console. And yeah, that's actually kind of the girth of the functionality of the whole project here. If any of this doesn't make sense to you, what we're about to go over now as far as the textual templating and styling and stuff, I highly recommend you just look at the textual documentation. It's pretty good. It's a little bit rough. It's pretty good, but it's a little bit rough. I'm not gonna lie. You know, just do your thing. Ask ChatGPT. Look at Stack Overflow. Look at the docs. You'll eventually get it. It's a little frustrating, but it is a really cool way to have like pseudo native apps. Kind of, it's actually run in the terminal, but it looks kind of like a native app. We will pull in our imports here, and we will start by defining a product list item. So we'll do class product list item. It's going to inherit from list item, and we are actually going to yes, take the product, which is a type compute product. We're going to return none. Not that it matters because I haven't typed most of this other stuff anyways. But here we are going to define a textual label, and it's going to be equal to a label. And that is going to have as parameters text dot assemble one of these days. And then I'm gonna go ahead and copy and paste this just because I don't want to mess up typing this crap. So here we're basically just creating a label, and we're formatting it all nicely and everything, and we're just gonna have that set to this label variable here, and then we are also going to super init, and we don't need to keyword this, super initialize as a label, and then self dot product equals product. And as most of you probably know, the super init call, it invokes the constructor init initialization method of the parent class, which is of the list item. So when we call super init and we pass in the label, we're actually calling init the init method of the super class, which is of parent list item, and we pass it to the label, if that makes sense. It's necessary because product list item inherits from list item, and list item probably expects something like a label widget and some other stuff during initialization. So unless we call super init, the parent class won't be properly initialized, and then it'll likely break things and behave unexpectedly. So moving on, the compute app class is the textual UI app, essentially, and the compose method defines its entire UI layout, and we're just going to go ahead and break it down part by part here. So if we go to if we create a computer class or a computer app class, which is essentially just our model for the whole TUI here, we'll do class computer app, and that will inherit from app, which is a textual thing, and then we will, oops, what the hell? We will set the title to AI compute input, yeah, product manager, that's fine. And then we'll set the CSS path to textual.css. And then we will, define a compose method, and it's going to return a compose result. And we're going to start off, we're going to yield. This is just how Textual builds its graphics here. So we're going to spell yield right. And we're going to yield a header. And it's going to, this is just one of the parameters that you can pass into it. So show clock will just show the clock in like the taskbar of the application. And we'll work on our form input. So if we yield, again, a grid, capital grid, and we pass into it a few things. So we'll do a label, and this will be name, and then next to that we will have an input, and we are going to give it the ID name and the placeholder here, placeholder equals, when we just put GPT-4, which is just so yeah, now we'll do another label, yes, which will be a provider, and it will be a select, and then we're going to need to do a little select, and we'll need to do a p.value, p.value for P and provider, ID is provider. Then we'll have another label, price USD, placeholder, yeah, we'll do that, and that's fine. We'll ID it with price, And then we'll have a compute hours label, input placeholder with that, sure, ID hours. And then we will have one more label, which is the hardware type. And we will select h value for h in hardware type. We'll ID that with hardware. That looks all good. And then we will have a button add product. This will be the add button. And then we will have a variant primary. Actually, if we look textual docs, buttons, you can see the different kind of buttons that you can choose from here, like the pre-CSS styled ones. And the names of those, are all right here. So yeah, if you want to change the styling, like preloaded styling, you can do that. So we have variant as primary, and then we will add classes button, and this is to be a query selector for our CSS file. And we will give the form an ID of form. Hopefully that's all right. And then now we're going to create a horizontal row here. So we're going to yield horizontal, and that is going to have a vertical in it, which will have that that list of the objects with the two buttons, the two JSON button and then the post button. So vertical, we'll do that, and we'll have a label here. You can kind of see how this is getting how they do the templating here. So label is products list, and then the ID is going to be product label. That's fine. And we'll do list view, which will be ID product list, and we don't need a classes here. And then we will also have a horizontal, which will have a button, which will have our, I'm gonna go ahead and just paste this button in here. Actually both of these buttons I'm gonna paste in here. So this will be our view JSON button and our post button, all like that. And then our ID for that little section is going to be JSON button wrapper. And then we're going to close this, comma that, and then set an ID on this for the whole container here. That will be list panel. We have that other quadrant to do here. We've got the list panel, and then vertical. And this is going to be a static, yep. And this will actually, we're gonna have it say something like this. And we will set an ID equal to detail, and classes equal to detail static. And then we will need to ID that entire container as detail panel. And we will add some classes for the query selection in the CSS file. So classes equal to detail panel. Yep, just like that. And then that whole thing will be wrapped in a container, which will be ID equal to main area. And then we should close this, and hopefully it's all happy. It looks like it's fine. And then after that, we are going to yield the footer, which is just a built-in textual thing. So next, we will define an onMount method. Oh, something's wrong here. Oh, it looks like something we forgot to close. For this here, it looks like maybe. Oh, we just forgot. A stupid comma here. All right. I guess we can do this too. All right. So now, after we yield the footer, we are going to define an onMount, which just means when this class is loaded, essentially. So onMount self return none. So we will do self.products, and this is just going to hold our products that we are creating in the actual client application itself. It's going to be an array, or a list rather, and then we'll self.showJSON, which is just a flag for that button. We're going to start that off as false, and then self.current products in case we input multiple products in the client application. We can switch between them in that list view that I showed earlier. So then we're going to, we want to initially hide the post button since the JSON view is off. So we'll do post button self.query1 post button, and it's going to be of type button. And then we're going to post button.display, display, it's going to be none. And then when we press that button, we need to define a method for that. So we'll do def on button press. Nice. Event button press. Yeah. So this is the event. Essentially it's just, I mean, it's very similar to web development. Like this is this would be like the event listener here. So none. So we're going to match event.button.id. And then the case add button, we are going to try name equals self.query1 name input.value, correct? And this is just getting the values from those inputs, the text inputs. Provider, going to be provider, self-query1 provider, select.value, yep. Price is going to be casted to a float, same thing. We're going to select on price, and it's going to be input.value. And then see if GPT can get this last one here. So hours, same sort of thing. And then hardware is going to be of the hardware type, query1 with the selector hardware. And we're going to get the value from that. See, not so bad. And now we're going to use that information to build that class. So product is be equal to AI computer product. And we get to do this because we automatically mapped all of this stuff here to our data class model. All right here. Self.products.append the product. Our list view is going to be self-query1 product list view, and our item is going to be a product list of the product, and we're going to append that to our list view.append item. View.index is going to be equal to the length of our list view of children. List view dot children -1. Our self.current product is going to be equal to the product, and self.show JSON will be equal to false. And then we are going to render the detail, which will be that initial product view on the right quadrant. And then we will accept exception as E area. So self.query detail static update. We'll just paste that in here, I guess. And then we need to, we already have the cases here. So case toggle button, we are going to show the JSON. So self.show JSON is going to be equal to not, yeah, we're gonna have to toggle that. And then we're gonna render the detail. Self.render detail. And then if we hit the post button, we are going to, and if we hit the post button, if we have a product, so if this should always be true, but self.current product, JSON data is going to be equal to self.current product to JSON. This is to JSON. Self.query1 detail static update. And we're going to update the text, or update it with text. Posted JSON data to server. Yeah, that's fine. And then we'll color it green. And then close that out. Otherwise, we will not have anything to, we won't have anything selected to post. This should never happen, but just in case. So yeah, this should be fine. And then here, we're going to need to do a new definition, or a new method here. And we'll do on list view selected. That'll work. Not the parameters though. This will be self message list view dot selected. Return none. And self dot current product is going to be the message item dot product, and self dot show JSON is going to be false. And then we're going to have to render the detail. And I wish we were done, but we're not quite done. Render detail is going to return none. And then detail is going to be equal to self.query1 detail static. That'll work. And our toggle button is going to be equal to the JSON, the JSON button there. And the post button, we're going to need to define that as well. Post button. Yep, that'll work. And then here we'll do if self.current product. So if we have a product already saved, then product dict is going to be equal to self dot current product to dict. That way we can get that information in the client view, and then toggle button dot label. We're going to change that to be hide JSON if self dot show JSON. Yes, else view JSON. That'll work. And this next bit is going to show or hide the post button based on the JSON toggle state. So post button dot display block if self dot show JSON, else none. That'll work. And then if self dot show JSON, we're going to try JSON render is going to be a syntax. So that will be of syntax, and then self dot current product to JSON. JSON correct, and then yeah, you can change the theme here if you want. Actually, let's change this to Nord just for fun. And then we'll do line numbers false, and then not this. We don't want this on a group. Yes, JSON render, and then we're going to catch that exception. And this will actually get rendered in as an error if there's something wrong with the JSON, which there won't be, but otherwise, I'm just gonna go back one else. We're going to detail dot update, update update. This is going to be a group view of the class on the right. When it's not JSON, it's just like a nicely formatted little text group. Oh, imagine that little text group. And then, so otherwise, else we will toggle button label view JSON, and then detail the update, select the product view. Yeah, select the product view. That's fine. And then we can go ahead and do our if name equals main clause here. So if under name is equal to main, then we're going to, when we don't need any of this here, we just call it like that. And where's this? Oh, this goes way back. Take that away. And yeah, okay, cool. So we gotta invoke that. Cool. So as you can imagine, like, this isn't the coolest thing ever, right? But you can extrapolate this to, maybe a notes application or a diet application or a weightlifting application or really, whatever you want. It doesn't look absolutely horrible either. It looks, not super great, but it looks pretty good for being native, especially Python native GUIs always kind of look trash. So if we add the product here and we click this, we view JSON, that flips over to the JSON, we should be able to post. And if the server is running, and of course, no wondering it wasn't posting because we never told it to. So I think that would probably be the main reason that we weren't posting here. So if we queue out of that, GPT didn't even help me. And then whatever, 1.1, 1.2, GPU, add product, select it, view JSON and post. And we look in the server and we did finally get our so cool. That was a little nerve-wracking, but yeah, so this code will be available on the website here. So you want to look at the code or copy and paste code, you can go here. It's all expandable and everything. You've got a little copy button here as well. We've got almost 150 subscribers now, which is pretty sweet. So if you guys like this, give it a thumbs up. If you think it's shitty, then give it a thumbs down, and I'll never ever do it again. Thank you.